For this video, we're going to be expanding on the concept of the conservation of momentum. We're going to be looking at essentially the same example, but we're going to introduce the concept of direction and momentum and how those two affect each other. So just like before, we'll have two train cars. The first one will be exactly the same as the last video. The mass will be equal to m, the velocity will be 20 meters per second. However, our second car, the mass will be 2m, but it's going to be moving 5 meters per second. Notice this time the two cars are not moving in the same direction. Specifically, car 2 is actually moving the opposite direction of car 1. So, whenever they collide and they couple together, their mass will be 3m, but what about the velocity? How high will the speed be? And in addition, what direction will it be in? Will the car be going to the left or to the right? Recall that momentum is defined as the mass times the velocity. Velocity is actually a vector, so it actually has a direction associated with it. And the conservation of momentum states that P1 plus P2 is going to be equal to P3. The total momentum inside the system must remain the same. For us, that's going to mean that M1 times V1 plus M2 times V2 equals M1 plus M2 times V3. So, in this case, our M1 is still labeled M, V1 is 20. Notice how I've made this a positive number. Our M2 is 2m, but in this case our velocity is going to be -5. I do this because it is in the opposite direction of the first car. I've defined just arbitrarily that the direction right that the first car is traveling in is the positive direction. Therefore, car 2 that is traveling to the left is traveling in the negative direction at 5 meters per second. And once again, we're getting back to our equation. All this is going to be equal to 3m times v3. So then we have 20m minus 10m equals 3m times v3. Therefore, 10m equals 3m times velocity of 0.3. Therefore, our velocity at 0.3 is equal to 10m over 3m, or 3 1/3 meters per second in the positive direction, or going to the right.